Four particles, each having a charge q, are placed on the four vertices of a regular pentagon. The distance of each corner from the center is a. Find the electric field at the center of the pentagon. Consider the situation when all five corners contain charge q. In that case, due to symmetry, net field at the center will be 0. So, if we remove one charge, then there will be some electric field. So, we can say that field due to one charge equal to net field due to other four charges. So, here at center O, the electric field will be equivalent to field due to single charge at E. So it will be Q upon 4 pi epsilon naught, and this distance is given as A. So A square, and its direction will be along EO. Now, consider next question. Next question says, find the electric field at a point P on the perpendicular bisector of a uniformly charged rod. The length of the rod is L, the charge on it is Q, and the distance of P from the center of the rod is A. So this distance from center, suppose this point is M. So MP equal to A, and this is charged rod. And from center, we have put the limit like minus L by 2 here, and on the right side, it is L by 2. And we consider small charge element at this point, and due to this we find the electric field, and then we integrate it within the limits. So charge per unit length will be total charge divided by total length, Q upon L, and we are considering length dx, so charge on it will be dq, which will be Q upon L times dx. Now, due to this element, we find the electric field. So electric field dE will be dq divided by 4 pi epsilon naught and distance square. So distance square means a square plus x square. And dq is q upon L into 4 pi epsilon naught dx divided by x square plus a square. Now, here, if we resolve this, this angle is theta. So dE cos theta will be in this direction, and dE sin theta will be in this direction. Similarly, if we consider another charge element here at the same distance x, so it will be like this. It will be like this with same specifications. This angle is theta, this angle is again theta. So dE cos theta will be in this direction, and dE sin theta will be in this direction. And d sin theta this, and this d sin theta will get cancelled. So we can say that net electric field will be due to d cos theta component. So we find E due to entire rod. So it will be integration of dE cos theta. That is, we can put the limits minus L by 2 to plus L by 2, and the dE is Q dx divided by 4 pi epsilon naught L times x square plus a square times cos theta from here based upon hypotenuse. So it will be a divided by a square plus x square whole power half. So it will be integration minus L by 2. We can take QA 4 pi epsilon naught L outside. So it will be QA upon 4 pi epsilon naught L. And then inside the integration, minus L by 2 to L by 2. And then we put the value. So it is dx divided by x square plus a square whole power 3 by 2. Now here we put x equal to a tan theta. So bracketed term will become a square tan square theta plus a square whole power 3 by 2. So that will give a cube times sec square, then sec square theta inside, then 3 by 2 will give sec cube theta. So this is denominator. And differentiation dx will give a sec square theta d theta. So overall, in numerator there is a, in denominator it is a cube, so 1 upon a square will be left. So let's write it systematically. So if we put these values, so we will get E equal to, so let's integrate it first without putting the limits, so that will be easier. So integration from here, it is a sec square theta d theta divided by, in denominator we have got a cube times sec cube theta. So ultimately 1 upon a square integration 1 upon sine sec theta will be left, which is cos theta d theta, and integration of cos theta will become sine theta. So 1 upon a square sine theta. So we have got the value of integration. Moreover, sine theta can be found from here. It will be x upon root of a square plus x square. So 1 upon a square times x upon root of a square plus x square. So we have got the value of the integration. So electric field will be equal to QA divided by 4 pi epsilon naught L, and then integration is 1 upon a square times x upon a square plus L square, sorry, a square plus x square under root, limits minus L by 2 to plus L by 2. Now we put these limits and then we check what we are getting. So here this by 2, we can take this a square outside, then this a will get cancelled. So in denominator we will get only one a, 4 pi epsilon naught L times small a, and then here both limits will have positive effects. So we will write twice of 2 times this x will become L upon 2, and divided by this will become a square plus L square by 4 power half. If we simplify, we get q upon 4 pi epsilon naught L A times L divided by, from here this will become 4a square plus L square, and then 4 will be outside the square root, and then it will become 2. So 2, then root of 4a square plus L square. Now from here L will cancel out, and this 2 will cancel this 4. So our answer will be q divided by 2 pi epsilon naught a times root of 4a square plus L square. Thank you for watching.